That's kind of been done for me. As Matt said, I'm a software engineer at Rookout. I come from a background of low-level programming, and I really love learning new programming languages and using a ton of programming languages. So in my job, I mainly use Ruby, Java, and Go, but occasionally also C#, Python, JavaScript, C++, at home a little Swift. So a lot of everything, and I really love it. So that's about me. Now, at Rookout, we're developing a debugger for production. What that means is that when you use a normal debugger, you're placing a breakpoint and your code stops at that point so you can inspect it. With our debugger, it will continue to run, so you can inspect it. You can see what's happening at that moment, but by the time you see it, it's already a few steps ahead. So you can see what's happening at any point of your time, in your code at any point in time, without stopping it, which allows you to debug in production or other environments that aren't only local. Now, one day my boss came to me and told me, we need to add support for JRuby in one of our debuggers. And I had no idea what JRuby was, so I just went online and Googled it. So from the JRuby wiki, JRuby is a 100% Java implementation of the Ruby programming language. It is Ruby for the JVM. So that means it's Ruby running on top of the JVM. Which is pretty cool. So the first thing I did was kind of start with a tutorial app where I could kind of play with it and see what's going on. So I have this simple Rails server. That's just a very simple to-do app. You can kind of see it here. I can add to-dos, remove to-dos. I can do anything I want. Awesome. So what I wanted to do is run the same thing with JRuby. And I use RVM to manage my Ruby versions. So fortunately for me, RVM just supports JRuby out of the box. When I did this originally, I did need to RVM install JRuby, but since I already have it installed, I can just use it. Now the first time I ran this, I needed to run bundle install. I already have it configured, so I don't need to do that now. But back then, I needed to run bundle install. And I kept coming across various errors that looked kind of like this. And the reason I'm telling you this is because if even one of you encounters this error and I kind of save you from those 3 days it took me to figure out what's happening, I Googled everything, I tried everything, I reinstalled and installed JRuby and RVM like 15 different times, and nothing was working. But apparently what happened is when I was very, very new to Ruby, I set force Ruby platform to true. And what that does is force bundle to use native extensions when it's installing gems. And JRuby does not work with native extensions. So bundle was trying to force it to use native extensions. JRuby was not having it. And that was kind of causing this conflict and nothing was working. So a quick unset and suddenly everything was working. And so once I had done that, I just needed to Rails server again. And JRuby does take a little longer to load, a little more startup time, but eventually it is usually faster. So here we have our to-do app, and once again, all the functionality exists. So that's literally all I needed to do, and my app now runs in JRuby instead of Ruby, which is pretty cool. So now that I've got it running, I need to do what I was sent to do, which was to support JRuby in one of Rookout's debuggers. Now, Rookout supports both Java and Ruby. The Java debugger also supports any language atop the JVM, and so I kind of had to make a decision. Do I want to start working on the Java debugger to support JRuby or on the Ruby debugger to support JRuby? Now, in our Java debugger, we're using JVM API, and what that means is that I'll probably have to know a little bit about how JRuby works in order to support it in our debugger. On the other hand, on Ruby, we use Ruby API, so as long as it's implemented in JRuby, I shouldn't really need to know the internals. However, if I'm using JVM API to debug, I'll probably also be able to debug external libraries written in Java, and not only Ruby code that's being compiled using JRuby. So that might be a big plus for Java. On the other hand, with Java, we instrument bytecode, which is more boilerplate, and I'm going to have to really get into the internals of stuff. And if JRuby does some weird things, which it probably does because it has to conform to the way the JVM expects things to look like, then I'll have to deal with that. I'll have to find workarounds that might be a bit difficult, whereas in Ruby, we're using some built-in functionality. And using that built-in functionality, as long as it's built into Ruby, to JRuby, it should not be a problem. And the last point, which definitely goes to Ruby, is that a debugger for JRuby written in Ruby already exists, and it's open source, which is Prodi. In Java, there's no debugger for JRuby. So kind of looking at this, I was like, okay, let's start with Ruby. It seems the easiest. And so I started. Now, I kind of took that big task and split it into 3 subtasks. First, I wanted to run an app with our debugger attached. I wanted to be able to add a breakpoint, and then I wanted to be able to trigger that breakpoint and collect data. Now, when running an app, all I really had to do was, first of all, bundle add Rookout, which is just our gem for our debugger, and also require it and just initiate it in the code. So once I had done that, I was able to see if it would work. Now, this should work. It's pretty simple. It's just attaching our debugger. We're not even adding breakpoints. We're not really doing anything. Okay, but it's not. So the first thing I saw was that I keep getting this exception. The exception is in tracepoint.java. It says unknown event script compiled. And in order to understand this exception, we need to understand what tracepoints are. So tracepoints is a Ruby API, which allows you to sign up to certain events happening in the Ruby environment. Now, there are multiple events that we can sign up for. For example, we can have our callback called each time a function is being returned from, or each time a method is called. This is interesting if you're into writing tools for observability. This is the API to use for Ruby. Specifically, when we develop a debugger, we're going to want control over every line that is executed, and so we can use the line event. And the way we do that is pretty simple. We'll just create a trace point, sign up to the line event, and inside that callback, we'll collect locals and stack trace and everything we need to debug. Now, once we've created the trace point, we need to enable it. And enable accepts 3 parameters: target, target line, and target thread. And all 3 of these parameters are there to limit tracing to specific code objects, because we don't want to stop on every line that is executed on only specific lines, so we can use these to kind of narrow it down. And the most important thing here is target. Target is a code object, and it's basically the method we want to be debugging or put the trace point on. And in the example from the Ruby API, it uses the method function and kind of passes it a reference to the method we want to pass. And let's say I had the method. First of all, I'll probably have it as a string since I'm a debugger. I don't have the actual reference to the actual object. And even then, I'm not sure if I have access to it or where it really lies. So using this method function was kind of not possible. In addition, at Rookout, we don't want to see anyone's code. So instead of this, all we see is this. So I can see that I want to place a breakpoint on line 36 of tasks control, but I have no idea what function is there. So I'll need something a little bit more sophisticated. So tracepoints has an event also called script compiled, which is called every time new Ruby code is compiled, whether it be with eval, load, or acquire. Now, what I can do is kind of collect all these compiled scripts. And when it happens, the tracepoint also includes the instruction sequence, which was compiled. So I can collect them into a list of instruction sequences. And then later on, when I actually want to add a breakpoint, I can iterate over those instruction sequence, finding the correct instruction sequence given a certain file name, and then just place it on that file. So I solved that problem. That was the original problem when developing our Ruby debugger. But that's also the problem that I'm seeing now, because we signed up for that script compiled event, and it doesn't seem to know what that is. And so a quick Google search led me to this issue in JRuby. Unfortunately, it's still open. But basically, JRuby is just a little bit behind in the tracepoint API. And so basically everything we do in order to place a breakpoint isn't really possible at this moment. I will say that as a workaround, I could just trace point enable without any parameters and place a breakpoint on every single line. It will really impact performance, and since we are running in production, I didn't really want to do that. So I kind of went back to the drawing board. I was like, okay, I can't run this app with Rookout attached, so let's go back to the decision and choose Java. Now, we're going to start from the beginning. So once again, we need to run an app. Now, the way our Java debugger works is it's something called a Java agent. And with a Java agent, it's pretty similar to a regular program, but what happens is it runs along the JVM, original Java program in the same JVM. So you just have two apps running one alongside the other, where the Java agent has access to something called Instrumentation API. And Instrumentation API is pretty cool because it kind of allows you to control anything going around in your JVM. Basically, any class that is going to be used, you can change it entirely. So that's pretty cool. In order to add a Java agent to your code, to your JRuby running program, all you need to do is add it as a JRuby opt. So -j actually passes the option to the JVM and not to JRuby itself, and then the Java agent, and I passed it a precompiled jar that I created of our Java agent. So with that attached, I'll just go ahead and remove the previous Ruby rook. So once I've done that, I can rerun it, and hopefully this will actually be able to run. So what we see here is some logs from the actual debugger. We can see that it has successfully attached. It's kind of initiating all sorts of values. And Puma has started, and we can go and see that our app is running. And more than that, it's actually connected to our debugger. So we can see that here. Should be connected to our debugger. Just make sure. Not the time. Great, so we're going to see here that we have one application selected. We're debugging one application. We were able to attach to our debugger. The first task is done. So we're on to the next one. Adding a breakpoint. So I'll just go ahead and do that. Here's my code. It's a very simple task app, so I'll just go to my task controller, and in the create function, which is called every time we want to create a task, I'll place a breakpoint. So that's right over here. And once I've placed that breakpoint, it's pending. So we have all sorts of states for our breakpoint. Pending means we haven't yet successfully been able to place the breakpoint, but we might be able to soon. So no hope is lost. And I kind of expected this to happen. And the reason why is how we add our breakpoints, and actually a little bit about how the JVM works. So the JVM knows how to run Java bytecode. And what happens is that there are a lot of languages running on top of the JVM, right? There's Scala, Clojure, JRuby, and so on and so forth. So each of these languages have their own compiler, which will compile to Java bytecode, and then the JVM doesn't really know what it's running. It just knows it's Java bytecode, and that's what it knows to run. And what actually happens is that once a certain line of code is reached where a new class is introduced to the JVM, for instance, let's say on line 33, this is the first time the JVM encounters the item class, it's going to request the bytecode from something called a class loader. So it's going to go to the class loader and say, hey, can I have this bytecode? And if it succeeds in getting the bytecode, it'll just return the bytecode. And this bytecode can be anywhere. It can be compiled on the spot. It can be taken from a file or from a remote URL. The class loader can do anything it wants. It just needs to return that bytecode. Now, this has almost nothing to do with our program. What we do is, because of that instrumentation API that we have as a Java agent, we can interfere in the middle of that. So what will happen is we can add something called a class file transformer. And that kind of interferes in this process. So once again, the JVM is just going to ask for the item class bytecode, and the item class bytecode is going to be returned. But before the JVM starts to use it, it's going to pass that item class bytecode to our transformer, and just allow our transformer full freedom and control over what happens to that bytecode. And the new item class bytecode is going to be returned from the transformer. So let's say we had a program printing hello world, and the class file transformer decided to change that to print goodbye world. Well, that would work. We could just change anything on the fly at runtime, which is pretty cool, but we don't do that for that. We just add a breakpoint when this happens. So basically what I'm trying to say is that the class hasn't been loaded yet, right? I've never once used this task controller in my app because I haven't added a task yet. So it makes sense that it's still pending. So once I actually add that to do, it should work. So let's say I want to fly to Thailand. So that should work. Okay, that's weird, right? That's not on. Okay, let me try again. Go to RubyConf. That should work. Okay, that's really weird. Right, this should work. Okay, that's weird. Oh, okay. Okay, that worked. Okay, that's great. So that worked. Okay, obviously that did not work as I expected, right? So I kind of thought back to what was happening. With a few spaced out invocations, right, the first two to-dos that I was adding, nothing was happening, meaning the class wasn't loaded yet. We weren't able to place a breakpoint yet. But with many rapid invocations, the class was loaded, and I was able to place a breakpoint, and it was triggered, and everything was going great. And this just screams JIT to me. And so this was the point that I finally broke down and I said, okay, I need to know how JRuby works. I need to know a little bit about JRuby itself in order to create a debugger for it. So I found out that JRuby has 3 compilation modes. So the first one is interpretation, where just every line of code will be interpreted as it's run. So that's kind of slow on execution, but there's no compilation time, so the startup is much shorter. Then there's the complete opposite, which is compilation, which means that every line of code will be pre-compiled, or just compiled when it's needed, and then that compiled version will always be used. But the default mode is a mode that's in between them, which is the JIT mode. In JIT, which is just in time, only when JRuby sees a certain need for a class to be compiled, it will be compiled. And the certain need usually comes up when there's like a hotspot in the code, when there's a piece of code that's been run multiple times in a short time span, or things like that. So it's like, okay, this code is being run a lot, I should probably compile it. When it's compiled, it runs faster, there's more optimizations. The JVM itself can optimize compiled code. So that's the mode that JRuby usually uses, and that's also what I was seeing, right? Because at the beginning it was like, okay, so this is just a random piece of code, I'll interpret it line by line, there's no need to go through the whole class loading bytecode process. But then once I was running this code a lot of times, it was like, okay, maybe I do need this. So it compiled this. Now, fortunately for me, JRuby does have an option to just force it to always compile. So I'll just add that JRuby option here, which is compile.mode force. And that capital X is just passing options to JRuby. And this will even take even more time to load and to start up, because JRuby will compile every external library that you're using at startup. So everything that you're using will now have to be compiled. So that should take a while. That's okay. We're ready for it. And here we go. So let's just make sure it's running. We should have a blank slate right here. This will also take a lot of time on the first reload, because on the first reload, we're requesting things that haven't been requested before, and JRuby will go ahead and compile those things as well. So if I reload it now, it'll be much quicker. Let's just go ahead and clear these down here, just to make sure we start clean and fresh. And once I've done that, I shall place a breakpoint. And once again, I do expect it to be pending, because that class still hasn't been loaded. Or maybe it has. Probably the reload caused it to be loaded. But now when I add a to-do, like fly to Thailand, it should just immediately collect that. And I can see that down here. The breakpoint was triggered. So another step is done. Great. Now, the third step was collecting data. And I kind of was having a problem, because I placed a breakpoint. This is exactly the code I placed a breakpoint on now. As you can see, this is a very, very simple function. It doesn't really have any local variables. It doesn't really do anything. It doesn't create any scopes. But then, so I really expected, like, I don't know, one local variable and for that to be self. But when I was collecting local variables, I saw many local variables. And for instance, there's a lot of $v_number here, and just all sorts of things that I couldn't really make sense of. So what I did was just started kind of dissecting them one by one. So for instance, the first thing I saw here was that $self, which is really self, so I really need to collect that and kind of parse it differently. And I just went one by one and was eventually able to really collect the variables that I need. And for this, I'm just going to change the function which I placed the breakpoint on, just to kind of go to a more interesting function. So here we have our update function. And in update, it creates this ID and completed. And so we're just going to put a breakpoint right here. So we expect all these variables to be collected and to be shown correctly. So once I go and update a task, like that, the breakpoint should be triggered. Oh, well, let's see then. I placed a breakpoint under the if the task was completed, so let's just make that completed. And now that breakpoint should be triggered, and we see it here. We do see 2 invocations, which is weird, but JRuby does whatever JRuby wants. So we do see that I was able to parse all the locals. I was able to create a debugger for JRuby written in Java. This was really, really cool. So that's how I added support for JRuby in our Java debugger. Now, there's a lot of things that I learned along the way. And the first thing was that we can do awesome things. And I'm not saying that to brag that I did an awesome thing, but I'm saying that because while I was working on this, I was super frustrated. I started this out with kind of thinking that this would be easy, because as I said, we have our Java debugger that supports every language running on top of the JVM. We have our Ruby debugger that supports Ruby. JRuby should not be that hard to support, and I was expecting this to take a few days at max, but it actually took a few weeks, and every challenge that I spoke of took a ton of time. And so I really remember finishing this task and thinking, wow, that took me so long. Like, why did that take me so long? I'm kind of disappointed that this is how it turned out. But what kind of changed my perspective on that was that I was talking to people and I realized that I'm the first person that created a debugger for JRuby written in Java. And that's the only debugger you can use to debug Java extensions or Java libraries you're using in your JRuby code. And again, I'm not saying this to brag about my accomplishments, but I'm saying this because this is what I think of whenever I'm frustrated with a task now. So sure, I did waste time when I kind of tried to support it in our Ruby debugger, and eventually I needed to support it in our Java and stuff like that. But at the end, I did something awesome, and I had to go through all those pitfalls. I had to make all those mistakes in order to make that awesome thing, and it was totally worth it, and I think I did it the right way. Like, eventually looking back, I think starting with Ruby was the correct choice. So we can do awesome things. The second thing is to smash your keyboard. For me, that meant quite literally smashing my keyboard, because that's what led me to my solution. But I also mean that pretty generally in just try really random and weird things. Try the most bizarre thing, try the thing you know for sure won't work, because that just might lead you one step closer to your real solution. And it probably won't work if you don't expect it to work, but just like how it doesn't work might lead you to that, so smash your keyboard. And the third thing is do meet your heroes. And by that I mean talk to the people you're using their tools, you're using their projects, because I didn't think to do that. So I was talking about the parsing of the variables and all sorts of stuff that I kind of ran into when doing this. And if I had reached out to the maintainers, to people working on JRuby and who knew JRuby, they would have been able to tell me like that what my problem is and how to solve it. So that would have made it so much easier. But that's not the only thing. Second of all, I'd also be getting into some really interesting conversations and finding out some really interesting things about how JRuby works that I might not need, but I definitely like to know. And the third thing is that it doesn't only help me, but it also benefits them and the community. Because once I raised my voice, I voiced my issues and told them what was kind of hard for me when I was creating our debugger, I was actually surprised to find out that they were like, oh, maybe we can fix that. Like, maybe we could do something that would be so much easier for you or for anyone in the future to write these kinds of tools. And so the next time someone comes around, it'll be so much easier for them because we will have already made up a better solution and a better way to make things work. So talk to people, talk to the community, voice your concerns and your issues, as well as saying thanks, and because they do some really awesome things, as I said. So a community that kind of communicates with each other is it's a stronger community. So that's my last thing that I learned. And a question I usually get after talking about JRuby is, should I use JRuby? And I kind of wanted to look at the advantages of JRuby. Charles did talk about this a lot in his talk, so I'll just go over this briefly. First of all, integration with Java libraries, as well as Ruby libraries. So if you find like that perfect library, but it's written in Java, you can use it with JRuby, so that's really, really awesome. As well as running atop the JVM, and the JVM is really good with long-running applications, performance-wise, because it just optimizes it. The more the code is run, it optimizes it even further, as well as it works well with threads, and it's also usually very, very stable, so it's really good for long-running applications. On the other hand, CRuby does have its advantages. Most of CRuby's advantages comes from a larger community. Because, as I said, a larger community, people talking in the community, that makes the community stronger, and that makes the projects and the tools in the community stronger. Because there are more people in the community, more features can be developed, things can be developed and moved faster. If there's a problem you need to fix, there's probably someone out there that has already encountered that problem, whereas in JRuby, you might be the first person to be developing a debugger for Java in JRuby, so you won't really have anyone to turn to, you won't really have any Stack Overflow answer your questions. So CRuby does have that big advantage. It also has some more features because JRuby is just catching up. And also, obviously, if you want it interpreted, fully interpreted, like nothing compiled, then you need to go with CRuby. But in all seriousness, my response is, I don't know, you choose. And the reason for that is that every kind of app has its own needs, and everything will perform differently in your apps than in mine, so you choose. The only thing I will say is that choosing between JRuby and CRuby is pretty similar to choosing between just two programming languages, but the main difference is that you can kind of test them out. Like, you saw how easy it was for me to switch my app from Ruby to JRuby. So if you're just thinking of moving to JRuby, or just interested to see if that will kind of boost performance, just try it out. It's really that simple. So that has been me. Thank you so much. Thank you.